Hello, welcome to my channel, and in today's video we are going to learn the first chapter of our chemistry, that is periodic properties and variations of properties. So first of all we must know what is the meaning of periodicity. So periodicity is the phenomenon of repetition of properties after a different interval. So after a definite time interval there will be the repetition of properties, and that is known as periodicity of the properties. So what causes the periodicity? We came to know that the repetition of a properties after a definite interval is known as periodicity of the properties. So what causes the periodicity? So the repetition of a property of same outer valence cell electronic configuration at a certain interval of elements, that is known as cause, that is due to which the periodicity happens. So for example, we can see that in the first group, lithium, sodium, potassium, rubidium, cesium and francium. So at when you will see their electronic configuration, so at last the one element will be in the outermost valence shell of lithium, sodium, potassium. So lithium is in the atomic number 3, so configuration will be 2 comma 1. Sodium at 11, so 2 comma 8 comma 1. So finally the outermost valence cell will have only one electron. So this is the causes of periodicity. The repetition of same outer valence cell after a definite or a certain interval of elements, that is called periodicity. So due to this, periodicity occurs. So once again, let us know the definition. The repetition of properties after a different interval is known as periodicity, and due to the same repetition of same outer valence cell electronic configuration of an element after a certain interval of element, that is known as the causes of periodicity. So now we will learn what are the trends in the modern periodic table. So what are the variations in the trends properties, like we can see their ionization energy, electron affinity, atomic radius. So what happens to these properties across the period from top to down, the group, bottom to the group? So it increases or decreases in the group or period. So that definition along with the trend of all these properties we are going to learn. So see here, ionization energy, it will increase across the period. Electron affinity, it will also increase across the period. So there are like this, not many more are there. So one by one we will learn in this video. So have a look at this picture displayed here. So first of all, we will learn the atomic radius, ionization energy, metallic character, electron affinity, electron negativity, and finally non-metallic character. So the first one is atomic radius. So we call it also as atomic size or atomic radius. So what is the meaning of atomic radius? So it is the distance between the center of two nucleus. So you can see very well in the picture displayed that the distance between the two nucleus, that is known as atomic radius. So the distance between the center of the nucleus and the outermost or the valence electron in the isolated atom, they are known as atomic radius or atomic size. So we have known the definition, and what is the trend of this atomic radius across in a period and in a group, we are going to see. So in period, the atomic size or the atomic radius will decrease from left to right. So from in the period, what will happen to the atomic radius? It will decrease from one to the next. So why is there is a decrease in atomic size across the period? Because the positive charge on the nucleus will increase across the period from left to right. So as due to the increase in positive charge on the nucleus, the electrons will be attracted with a greater force towards the nucleus. So as there is a positive charge increasing and the electrons are being attracted with a greater force towards the nucleus, so what will happen? This will result in the decrease of atomic radius or atomic size. So due to the greater attraction of electrons towards the nucleus, it will result in the decreasing the size of a atom. So atomic size will decrease across the period. So trend in a group that atomic size or the atomic radius will increase down the group. So why it will increase? As we know, the number of occupied electronic cell will increase in the group. So due to that, atomic size should increase, but because of a electronic cell which will act as a screening effect or the shielding effect, so due to this shielding effect, the outermost electron will not experience the full attractive force of the nucleus. So, the effective nuclear charge will be less. So, the effective nuclear charge will be less. So, due to this, the effect of increase in the number of electronic cell will overweight the effect of increase in effective nuclear charge. So, due to this, what will happen? The atomic radius or the atomic size will increase down the group. So what is overweighing? The effect of increase in number of electronic cell is overweighing the effect of increase in effective nuclear charge. So why does the outermost electron does not get more effective nuclear charge? Due to the screening effect or the shielding effect of an electronic cell. So it does not allow the outermost electron with a full attractive force, so effective nuclear charge is less. Next is ionization energy or ionization potential. So the energy required to pull out the most loosely bound electron from an isolated gaseous atom to form the gaseous cation is called the ionization energy. So we you can see on the screen that the lithium, the gaseous state, so the energy required to pull out the most loosely electron from the isolated gaseous state to form a gaseous cation or ion, that is known as the ionization energy, or we call it as the first ionization energy. So always the first ionized energy increases, so the second ionization energy will be more than the first, third will be more than the second, because more energy shall be required to pull out the second electron, third electron, like that. So what are the trends of this ionization energy? So ionization energy will increase from left to right across a period. So why it will increase? Because atomic size decreases and the charge on the nucleus will increase across the period. So when we move from period from left to right, so the more energy is required as the electrons are more held more tightly by the nucleus, so more energy is required to pull, so ionization energy increases across a period. And what is the trend in a group? The ionization energy will decrease down a group as the atomic size increases in the group and the nuclear charge also increases. So the effect of increase in atomic size will overweigh the effect of nuclear charge. So what will happen? Ionization energy will gradually decrease from top to bottom in a group. You can see on the screen the first ionization energy of magnesium and the second ionization energy. So the second will be always more than the first, third will be more than the second. Why? Because more energy is required to pull the second electron from an atom or the third electron, like that it is very hard. So how the number of electron will increase second, third, like that, so the energy also required to pull out the electron will increase from first to second, third, like that. So what are the trends we learn in this second ionization in this ionization energy? That it will increase across a period, but ionization energy will decrease in the group. So next is metallic character. We also call it electropositive character. So it is the tendency to lose electron from the outermost shell to form a positive ion or cation. So what is this metallic character? It is the tendency to lose the electron from the outermost shell to form a positive cation. And what is the trend in this metallic character, that this metallic character or electropositive character will decrease from left to right in a period. So it will decrease from left to right in a period. In easy method, as we can see, it is displayed on the screen that the lower will be the ionization energy, the greater will be the metallic character. So this is the one of the example or the way to remember this metallic character, that the lower ionization energy, more will be the metallic character. So where is the more ionization energy? In the period. So we know that the lower ionization energy, greater will be the metallic character. So where is the lowest ionization energy? In the group. So where the metallic character will be more? In the group, because the lower ionization energy is in the group. So the greater metallic character or the electropositive character will be uh, from going down the group. So it will metallic character will increase, and in the period the ionization energy is high, so metallic character will be low. Thus we can conclude that metallic character decreases left to right across a period, and metallic character increases going down a group. And the alkali metal is the most metallic element of the period. Which metal is the most metallic element? Alkali metal. So the next is electron affinity. So it is the amount of energy released when a natural atom or a molecule gains an electron from outside. So this is known as electron affinity. The negative sign of this will means that energy is released in the process. So what is the trend of electron affinity? It will become more and more negative across the period. It means it will increase in the period, and electron affinity will decrease down the group. Next is electronegativity. So electronegativity is the tendency of an atom to attract electrons to itself. So what is it is a measure of an atom's attraction for the shared pair of electrons in a covalent bond. Or the larger will be the electronegativity of an atom, the more atom will be pulled or shared towards it. So this is the electronegativity, that the tendency of an atom to attract electrons to itself. So, what is this electron affinity, electronegativity trend? That it will typically increase from left to right across a period, and the electronegativity will decrease down the group. So we can see that the ability of an atom to attract electrons when bonded is known as electronegativity. Non-metals will have high electronegativity, metals will have low electronegativity. It will increase across a period and decrease down the group. Next variation and the last variation is non-metallic character. So non-metallic character, we can call this electronegative character. Non-metallic character is due to electron except it is the tendency of an electron to gain electron and form negative ion. So this is known as non-metallic. What we have seen in metallic, the tendency to lose electron, but non-metallic is the tendency to gain electron. And what is the variation across the period? Non-metallic character will increase from left to right across a period. So halogen is the most non-electronegative or most non-metallic element. So what will the trend in a group? Non-metallic character will decrease down the group. So the question is why there is a increase across the period, because the increase in nuclear charge and decrease in atomic size. So which is the most electronegative? Halogens are the most electronegative. So next we will see in the nature of metal oxides. When the acid and the base will react, it will form salt and water. And the non-metals form acidic oxides like CO2 plus H2 will give out H2CO3 carbonic acid. So zinc, aluminium, tin, these are the amphoteric oxides. So next carbon monoxide, nitric oxide, nitrous oxide, water, and some more important, they are known as neutral oxides. So what is the meaning of amphoteric oxide? Means the amphoteric oxides are the oxides which will react with both acid and alkali. So we know that metals forms basic oxides, Non-metals form acidic oxides. For example, CO2, SO2, SO3, N2O5. So these are the acidic oxides. Zinc, aluminum, tin. These are the amphoteric oxides. Carbon monoxide, nitric oxides. They are neutral oxides.